Yes. Good evening, friends. Welcome to the session once again. Today, in this session, we are going to continue with environmental geography. Today is the second session. Yesterday, we have conducted the first session under environmental geography. We will continue from the law of limiting factor. Okay. Yesterday, we have seen what is the basic subject matter of environmental geography as such. We have seen the basic concept of what is this biosphere. We have seen what is this ecology, and also we have seen what is this ecosystem approach. Application of general system theory in the study of ecology is nothing but the ecosystem approach. Under this ecosystem, we have seen there is a structure. Under this structure, we have seen we have this biotic component and abiotic component. The interlinkages between biotic and abiotic component in the ecosystem is nothing but by the carbon-based substances, okay, which we have seen already. Organic matter. And also at the same time, we have seen ecology is nothing but the interaction among different organisms, among themselves, and also at the same time, their interaction with the surroundings. Surrounding, in a sense, the abiotic factor like the soil condition, that is the land area, the water, the air, everything combines together and is known as the study of ecology. And in order to understand this ecology, we apply general system theory, that is known as ecosystem approach. Clear? Now, as we wait for some more learners to join in, let me just take you through some important information from the Unacademy platform. You see here, because of popular demand, the last date for this introductory offer for UPSC CSE 2023 has been extended till 19th of January. Now, the original price is this 78,999. With 10% off, you get by around 70,999. A massive reduction of around 8,000 rupees. But with the application of an educator code, you get further discount. So, 78,999 worth is reduced to 63,898. You can use my educator code, that is SUNEP, this is my name, 10. Okay. Along with this, if you are going for this UPSC CSE 2023, 18 months combo will be the right fit for your preparation. Why? Because by the time you will be appearing prelims in 2023, this month, 18 months will be in this time period. Clear? Additionally, you will get 20 GS book. Also, you will get an opportunity to test in to sit in the test series. Clear? Unacademy always comes up with certain courses and programs depending on the relevance of the upcoming exam. Last year, Unacademy ran this last mile program. The success rate, I'm just giving you as an example, is out of all India rank 1 to 20, 7 learners were there from this particular session. Also, out of all Indian rank 21 to 100, 20 learners were there. From all India rank 101 to 761, around 143 learners were there. So you can just calculate the success rate. Therefore, if you also want your name to be in this kind of a successful list, then you can subscribe to any upcoming courses that gets launched in the Unacademy platform. Clear? Now, your UPSC Prelims is just around the corner. It is 2022 Prelims is in the month of June. Taking this into consideration, another course is starting on 19th of January. Kindly don't miss Mission 2022, Lakshya 2022. Okay, all of this. Now, Every Sunday in Unacademy platform, we have UPSC CSE Comp happens every day, every Sunday at 11 a.m. There is no other better way in order to revise what you have studied through this MCQ. On the other hand, you will get an opportunity to self-assess, okay, at what level of preparation you are, in which area you need certain improvement. So what can be a better option than to attempt this? Additionally, you are getting a scholarship from a pool of something around 4 crores of rupees. It is not like if you are the topper in this particular, or if you are number 1 or rank 1 in this UPSC Comp, you will get scholarship. No. Even if you come within 500, top 500, you end up getting scholarship of 25%. Okay, so that is the upcoming Sunday, that is 16th. Kindly attend. You just have to devote your 60 minutes. That's all. You can use my code, that is SUNEP10, okay, as an enroll code. Clear? Kindly attend. Let me tell you once again, any competitive exam, UPSC or any other state services or other exams, it is no longer a university, college or a school exam. It is a competitive exam, which means there is no pass mark. It is a merit-based exam. It is very important to know at what level of preparation you are. Okay, therefore by attending such competitions or compat, this compat will be attempted by your peer group only, okay, your co-aspirant. Therefore you will come to know at what level of preparation you are, isn't it? Just by sitting at home, just practicing day in and day out without self-assessment of how others are performing, it is just like a blind person, okay, trying to figure out the things, okay. Therefore it is very, very important. You need to assess yourself vis-a-vis the other person, because the exam is a competitive exam. Keep that in mind, okay. With that basic introduction, let us continue with our discussion today. You see here, yesterday we have seen this abiotic component. Under this abiotic component, we have seen we have started yesterday, that is loss of limiting factor, which is also known as Lippic-Blackman law. Okay, what is this? You see here, yesterday we have already discussed regarding the abiotic component. Remember, we are discussing the structure. Always remember the base on which we are discussing. Structure of ecosystem. Under structure of ecosystem, we have this abiotic component and biotic component. Under abiotic component, we have climatic conditions, organic component and inorganic component. Clear? Now, under this, one important law is known as laws of limiting factor, which means, you see here, the example is given by this barrel. The figure which is in front of you, it is just an illustration or an example to explain the concept or the meaning of this laws of limiting factor. Now say for example, if you pour any liquid here, okay, this is the barrel, but the barrel shape is not uniform on the top. It is divided like this. Now, if you put any liquid in this, what is the level up to which a liquid will be able to fill? Up to what level? It will be determined by this. The lowest one, the lowest level in the barrel will determine the level up to which the liquid can be stored. Okay, suppose up to this level a liquid cannot be stored. Why? Because it will flow out. Up to this level liquid cannot be stored. Why? Because it will flow out. Now the lowest level will determine the level up to which a liquid can be stored in this particular barrel. Clear? Similarly, laws of limiting factor under ecosystem means in the ecosystem, for any organism or for that matter for any kind of activity in the ecosystem, it requires certain type of inorganic component organic component, and also climatic factor. The inorganic component refers to all of this carbon, calcium, magnesium, iron, okay, taken up as a nutrient by organism, and when they die and decompose, it is returned again to the ecosystem. These are the inorganic component which is required by any organism in the ecosystem. The organic components such as protein, lipids, chlorophyll, again very important. This organic component, which is a carbon-based molecule, connects or links the abiotic and biotic component in the ecosystem, and also the climatic factor. For each plant or for each organism, it requires certain type of climatic condition, that is temperature and rainfall. There are certain plants which are water loving. There are certain plants which cannot tolerate high amount of water. Similarly, there may be organisms which love or which require a lot of temperature. There may be plants or organisms which cannot survive in high temperature or high sun insolation. Okay, shade loving organism or plant. Therefore, depending on the organisms, the amount of inorganic component, organic component and climatic conditions will vary. On the other hand, in each and every different places on the earth's surface, the supply of inorganic component, organic component, climatic condition differs. And let me tell you, in each and every different ecosystem on the earth's surface, the supply of all of these abiotic components are different. Now, that is on one hand. On the other hand, I have just mentioned to you, different organisms require different amount of all of this. Now, the interplay among themselves is such that it is defined by this law of limiting factor. I have just given you an example. The level of water that this barrel can hold is the lowest level in the barrel. Okay, this one, up to this level only, which means in any ecosystem, the minimum amount of any organic or climatic factor will determine what will be the condition of this ecosystem. Means how many organisms it can support, or what are the organism it can support, okay, is determined by this, the minimum amount which is present. Say for example, suppose I have this light here, okay, kindly follow the pointer, very important point. See, the application of this is very important, okay, application. See, we are going to apply this particular law. See, kindly follow the pointer, come to this, it is a light, okay, this particular section represents this light. Here, light is quite sufficient. Now, say for example, if this particular section of the barrel, if I remove and if I cut it here, you see here, if I cut it here, okay, kindly follow the pointer, if I cut this barrel here. Now, you tell me, till what level a barrel can hold a liquid? Now, potassium level, the lowest level is replaced by this, which means now the water is able to hold up to only this level, which means organism which require, or organism, presence or the absence or the organism or an ecosystem or a place that can sustain or support any organism, okay, will be determined by the amount of light intensity. Why? Because light intensity is the lowest level here. So it will determine the presence or the absence of the light will determine the type of organism that you will find. That is known as law of limiting factor. Let us take some example. Ecosystem type, that is a terrestrial ecosystem or aquatic ecosystem. Their physical and chemical characteristics are, the physical characteristics will be in the terrestrial ecosystem, light, temperature, precipitation, soil fertility and wind. Chemical characteristics in the terrestrial ecosystem will be dissolved nutrient in the soil water. In the aquatic condition, you see here light penetration, temperature, water current. chemical, dissolved nutrient, dissolved oxygen, salinity. If you correlate with the law of limiting factor that we have just seen, we'll take the same example about the barrel, okay, like this. So each of the section of the barrel is represented, say for example, if it is physical, by light, temperature, precipitation. Now, which one is the lowest in supply will determine the type of organism that will be present in that particular ecosystem. Say for example, in many terrestrial ecosystem, the limiting factors are the nitrates and phosphate. That is, they are in the minimum amount. In the aquatic system, it is the photic zone. Say for example, in the aquatic system or in the water or in the ocean ecosystem, the ultimate source of energy is the sun insolation. Now the sun insolation, when it strikes the water surface, it diffuses up to a certain extent. The sun insolation is not able to penetrate up to the depth of the ocean or the ocean bottom, because light can only penetrate up to somewhere around 200 meters from the sea surface or sea level. This region is known as a photic zone. Maximum organism will be here. Why? Because this is where you get sufficient amount of oxygen by the process of photosynthesis by phytoplankton or diatoms. Okay, so these are the example. So in aquatic ecosystem, photic zone is one of the limiting factor. Okay, see, laws of limiting factor. Clear? Now, there is another law, that is law of tolerance, given by V.E. Shelford. What is this particular law? Kindly follow the pointer. Remember, we are discussing the structure of the ecosystem. Under the structure of ecosystem, we are discussing the abiotic component. You see here, kindly follow the pointer. In the x-axis or horizontal axis, it is the axis of environmental gradient. Environmental gradient, in a sense, temperature, pressure, different soil conditions, so on and so forth. Okay. In the y-axis or vertical axis, it is represented by the population size of any organism. Now, the presence or the absence and also the population of organism in the ecosystem behaves in this manner. How? If the environmental gradient, that is the temperature, the precipitation, the soil type, okay, all in all, I can say the abiotic component, that is the inorganic component, the organic component, the climatic factor, if it is lower than the required one, if the concentration or the presence or the condition is, say for example, if the temperature is too low or if the rainfall is very less, very dry area, okay, everything is very low, then the organism will be absent from such a region. It is known as, for this organism, it is known as the zone of intolerance. Now, you increase the temperature, now you increase the rainfall, okay. Now, this climatic condition we are just taking as an example. There are other organic and inorganic component also. Now, you increase, if you increase gradually, see environmental gradient, it is low, this is high. So, I am increasing the environmental, that is increasing temperature, increasing precipitation, that is the rainfall, then the number of organism, then the organism will start to arrive in the ecosystem. It is not like all the organism will come together at the same time. Initially, there will be certain organism which will come in a very small amount. Now, you further increase the environmental gradient, that is increase in temperature, increase in moisture content, then the number of organism, that is the population size of the organism, will increase gradually, will increase like this. Not gradually, exponentially it will increase. This region, okay, from the environment completely absent to few environment that comes in the ecosystem is known as the stress zone. Yes, the organism will be present here, but in a smaller amount, smaller population, okay, the size will be less. And the reason behind this is, it is, yes, organism is there, but they are under immense stress. Why? Because the adequate or the optimum level of environmental gradient is not yet achieved. These two combined together is known as lower limit of tolerance. Okay, now you keep on increasing the environmental gradient further. Means I increase, example, the temperature and the precipitation, that is the moisture content or the rainfall. If I increase, the number of organism increases exponentially like this. Okay, why? Because this particular environmental gradient is optimum or conducive enough, fitness and growth maximum, and it will increase exponentially to some certain level. Beyond this, even if I increase further the temperature, example, and the moisture content, that is the precipitation, the population size of the organism does not increase exponentially infinitely like this. Okay, it reached a peak point, after which even if I increase the environmental gradient, it will come down. This is the population size. Okay, will come down. Now this particular area range where there is a peak in the size of the population, and further if I increase the environmental gradient, it comes down up to this, is known as optimum tolerance range. If I increase further, example, the temperature and the moisture, organism becomes few. Why? Because I have already mentioned to you, for each and every organisms, okay, the plant or animal, there is a certain optimum level where it survives. Less or more is not good. There is a certain value. Therefore, even if the temperature and precipitation, in the example that we are taking, the climatic factor, even if I increase more, the organism is going to be less. Very few organism on the higher side. It is also known as the same replica, that is the stress zone. And if I continue further, the supply of temperature and the precipitation, organism will be completely absent, which is known as the zone of intolerance. So this is known as upper limit of tolerance, lower limit of tolerance, and the middle section is known as optimum tolerance range. This is how the behavior of organism happens, or the size of the population of organism in the ecosystem behaves depending on the abiotic factor in the ecosystem. Clear? We have seen two important laws, that is law of limiting factor, and the second one is law of tolerance. Is it clear? Let us quickly go ahead. We have finished the abiotic component. Let us go to biotic component. Biotic component of the ecosystem. Okay, we have seen producer, consumer, okay, decomposers. Producers are autotrophs, photoautotrophs, and chemoautotrophs. Obtain their energy from the oxidation of organic substances without the use of light, that is this chemoautotrophs. Okay, bacteria capable of feeding on hydrogen sulfide is one of the example for the energy. Okay, then comes this producer autotroph is plant. It takes the sun insolation for the process of photosynthesis, thereby manufacture their own food. Okay, chemoautotroph is obtain their energy from oxidation of organic substance but not using the sun insolation. Okay, bacteria capable of feeding on hydrogen sulfide for their energy is one of the example of this chemoautotroph. Consumer, it is known as heterotrophs. Consumer can be number one, macro consumer. Okay, under macro consumer they are primary consumer, secondary consumer, tertiary consumer. Tertiary consumer can be a top carnivore, that is eagle and shark, and omnivores. Clear? That consume both plants and animals. Okay, now micro consumer. Micro consumer can be It is important. Decomposers and detritus feeder. What is the basic difference between these decomposers, which is also known as reducers, and these detritus feeders? Decomposers are reducers, that is, they feed on dead organism, recycle the nutrient again. Okay, decomposers feeds on the dead organisms and recycle the nutrient. Example, bacteria comes under this decomposer. On the other hand, you have this detritus feeder. What is this? They feed on partially decomposed organic matter. Okay, decomposers feed on dead organism. Detritus feeder feed on partially decomposed organic matter. That is the basic difference. Contributing to the process of detritus breakdown. Example, earthworms, termite, crabs, they are all detritus feeder, which means they feed on partially decomposed organic matter. But the decomposers as such, example, bacteria, feeds on the dead organism itself. Clear? Now, we have seen the basic structure of the ecosystem, that is biotic and abiotic component. Now let us see some functional characteristics of an ecosystem. What is the functional characteristics of an ecosystem? Okay, now functional characteristics of an ecosystem is the rate of material or a nutrient cycle which happens in the ecosystem is which happens in the environment is one of the function. Rate of nutrient cycle means the nutrients, the supply of nutrients taken up. Just now we have seen the role of this micro consumer, the decomposers and the detritus feeder. They recycle this nutrient. The flow of this, the rate of material or nutrient recycling or the cycling that is happening, that is one of the function of the ecosystem. The second is the rate of energy flow through the ecosystem. You see here, autotrophs, okay, is able to manufacture their own food, that is the plant, from the sun insolation. It is consumed by herbivore. The herbivore is further consumed by the carnivore. So in each process of this cycle, energy is transferred. First, the energy of sun is observed by the plant, which is the autotroph. This energy, which is observed by the plant, some energy the plant uses for itself, for its own maintenance or uptake. The remaining or some of the energy is given away when this herbivore feeds on this plant. At the same time, since it is energy, during the process of transfer, there are certain energy that get lost. So all of this process is another function, that is rate of energy flow through the ecosystem is another function. Ecological regulation processes is the another third function performed by the ecosystem. The abiotic component of the ecosystem supply all necessary nutrients for the producers to synthesize organic food for the whole ecosystem. The biotic and abiotic component interact to regulate the ecosystem, that is through which process. Okay, through which process, see, till now, right from your school days, you are reading about photosynthesis, respiration, okay, all of this. Now, the context with which you need to see this photosynthesis is in the ecosystem, the interaction of this biotic and abiotic component in order to regulate the ecosystem as such. Remember, we have just seen the structure of ecosystem composing of this abiotic and biotic component. Now, between these two substructure of the ecosystem, biotic and abiotic, there is an interaction which is going on continuously. Now, the interaction happens in order to regulate this ecosystem. And how it is done? It is done through photosynthesis, respiration, decomposition, parasitism, symbiosis, evaporation, deposition and precipitation. Clear? Now, Let us see the first function, that is the flow of nutrient or the nutrient cycle in the ecosystem. The first function of the ecosystem. Clear? You see here, nutrient, inorganic, they are carbon, oxygen, all of this. Clear? It is taken up by the green plant, makes a complex organic substance. When they die down, or when the green plant is taken up by some organism, after they die down, the green plant or the herbivores or carnivores, bacterial decomposition will take place. Now, after the bacterial decomposition, the nutrient is again cycled back to the soil, or you can say in the environment, which is available to be picked up again by the green plant. That is the entire cycle of flow of the nutrient, which is known as biogeochemical cycle. Biological, geo, that is involving the earth's surface, chemical, it is the chemical process. It is known as biogeochemical cycle. Kindly look at the figure which is in front of you. Kindly do so. This is the entire process of how interaction or the flow of the nutrient which is taking place in the ecosystem. And this function is and this activity, the rate of flow of the nutrient, is one of the function of the ecosystem. Clear? Kindly do so. You see here, energy from the sun, which is the ultimate source of energy on the earth's surface. We have seen the chemoautotrope. That is one exception, which means some bacteria feeds on hydrogen sulfide for their energy, does not require the sun insolation. If you just leave out this, the ultimate source of energy comes from sun, and the energy from the sun that is captured in order to manufacture their own food is the producer only. We cannot. Human being or animal, if you are hungry, if you just go out and stand in front of the sun, are you going to fill your stomach? No. Okay, but plant, producer green plant has that capacity of manufacturing their own food. Okay, so the ultimate energy from the sun is taken by the producer, that is the green plant. They manufacture their own food. It is consumed by the animals, okay, or it can be consumed by XYZ. Okay, now after this consumer, that is the animal, they die, it is decomposed by bacteria and fungi. Now these particular decomposers will add the nutrient into the soil, that is the nutrient pool, and this nutrient pool again is ready for the supply of this nutrient to the green plant. And this is how the nature of a nutrient cycle, flow of nutrient or biogeochemical cycle in the ecosystem is cyclic in nature, which means it flows from one to the other and comes back again. So it is cyclic in nature. Clear? Nutrient pool, let us see. Atmosphere, hydrosphere, lithosphere. Suppose if this flow of the nutrient involves only the atmosphere and not involving the water body or the land area, it is known as gaseous cycle. And this is how a gaseous cycle takes place. Oxygen, CO2 by the process of photosynthesis. Okay, enters and live in gaseous form from atmosphere to the organism and back to the atmosphere itself. If it involves the water body, it is known as hydrological cycle. If it involves the land, the soil, or the lithosphere, I can say in general, it is known as sedimentary cycle. That is regarding the nutrient flow or flow of nutrient in the ecosystem, or you can say biogeochemical cycle. The turnover time of various elements in the biosphere looks like this, which means the flow of nutrient its turnaround time is, we know the basic characteristics of the biogeochemical cycle or the flow of nutrient is cyclic in nature. So once this is moved from one place to the other, how long it takes to complete the cycle is known as turnover time. You see here, the turnover time of CO2 is only around 300 years. For you and me, for human being, 300 years is too long. But as far as the Earth system, ecosystem is concerned, and also compared to the other component, organic or inorganic, 300 year is very, very less. That's why we are talking about greenhouse gas, global warming, and we used to tell and we used to study or read that the global warming, climate change that we are experiencing today is not only because of the greenhouse gas that is generated by us now, but the cumulative effect of storing of this greenhouse gas in the atmosphere right from the time of industrial revolution. Clear? Now, CO2 turnaround time is around 300 years. Oxygen turnaround time is around 2000 years. Okay, you come here, nitrogen turnaround time is around 200 million years. You compare 300 years with 200 million years. Okay, 300 million years is very, very a small time period. Clear? Flow of energy, second function of ecosystem. Energy flow in an ecosystem. Now, the nutrient flow or the flow of nutrient in the ecosystem is a cyclic in nature. The energy flow or flow of energy in the ecosystem, on the other hand, is linear in nature. Okay, clear? Say for example, the autotrophs or the plants take the help of this photosynthesis, only way by which energy enters an ecosystem. This is how. Okay, if you don't remember or see, it is just for the illustration. If you remember, well and good. This is how the plant prepared the food by the process of photosynthesis. Carbon dioxide, water, okay, low chemical energy in the presence of the sunlight turns into glucose, that is high chemical energy, and oxygen, which is given out. So during the process of photosynthesis, in the presence of sunlight, CO2 and water interacts, giving rise to glucose and oxygen. That's why in the photosynthesis process, oxygen is given out, and the energy, this is the glucose, that is the food. Now, photosynthetic efficiency is ratio between the chemical energy fixed in the plant and the amount of photosynthetically active radiation. Okay, clear? Ratio between chemical energy fixed and amount of photosynthetically active radiation. So whatever the energy which is coming from the sun, only around 0.2% is able to be captured by the plant by the process of photosynthesis, which is known as photosynthetic efficiency. Okay, so we can say the photosynthesis process is also not that efficient. Why? Because it is able to fix only around 0.2% of the energy that is coming from the sun insolation. So 99.8% of the energy is get lost. Okay, that's why it is a linear flow, the energy flow in the ecosystem. It is lost. Okay, if it is a cyclic, then there is no question of lost. Okay, why? Because one goes, comes back again. Okay, but the energy flow is what? Energy flow is linear in nature. You see here, like this. It is the sun insolation, a plant, but during the process, we have just seen photosynthetic efficiency. It is only around 0.2%. Means maximum amount of the sun insolation is lost as heat. Now, this plant, if it is consumed by this particular organism, that is the consumer, out of this 0.2%, the plant will also require certain energy for its own uptake or upkeep, in order to maintain. Now, remaining, suppose if this organism consumer eats on this, okay, this organism consumer will not get the entire energy which is left behind after the plant reserve certain energy for its own maintenance. Some heat will be again released like this. It is lost. Now this will be consumed by this. Another heat is lost. Heat is lost continuously like this, and the energy flows linearly only. It is not cyclic in nature. Okay, remember. So energy, if lost once, it is lost forever. It is not cycle back as it is in the nutrient flow. Clear? We'll end the session here today. So this is how you see the comparative comparison between the nutrient cycling and the energy cycling. Extremely sorry. The comparative relationship between the nutrient cycling, okay, or nutrient flow or flow of nutrient and the energy flow. Nutrient flow is cyclic in nature like this, whereas energy flow is linear in manner like this. Light energy, heat energy goes out. Clear? Anyway, we'll end the session here today. We will continue tomorrow from this part. Okay, productivity of an ecosystem. Okay. Anyway, thank you so much for your patience and cooperations. We will meet again tomorrow at the same time. Okay. Bye bye. Take care and good night.